Hi, my name is Emmanuel Velez Roldan, and in this video I will be talking about my experience working with RL, with reinforced learning, to solve a problem that we have that consists of one differential mobile car with two wheels that needs to solve a maze of 45 degrees turn, mainly. And for this, we implemented a whole system with a camera and with a cenital camera, overhead camera, and also with our mobile car that has an Aruco in the top to be able that the vision can identify our car and the orientation of this one. And we also make a low layer, our low layer control of this project architecture is the PID controller that is in the Arduino, in the ESP32. That with this we can be able that our car can achieve the right RPM velocity of both of the wheels with the two encoders that we have that were the home run encoders. And the car was mainly made with the encoders, the motors, two DC motors, and step down H bridge, and that's it. And the whole system is with this low PID layer, and the main layer of this architecture is the RL that sends these RPM outputs to the low layer, and this low layer tries to achieve that velocity, right? First of all, we need to compare it to another to the same problem but with another solution. The other solution was the fuzzy logic that works with theory rules of with theory rules, right, of the fuzzy logic. And we have variable results with this because in general the RL seems to be more effective solving the maze because it's solving it in a 3 times faster than the fuzzy logic, but the fuzzy logic has less errors than the RL in the heading angle and the orientation, the velocity, but it's pretty much the same metrics. Is a very minimum difference between these two errors that we have of the fuzzy logic and the RL, but the thing with the RL is that is very much faster than the fuzzy logic, right? And the first limitation that we had was that, first of all, when we were trying to train our RL model, we tried to do it in simulation in a virtual environment, but we have a lot of trouble doing that because the reward function and the environment, right? Because we didn't have like the same model of the car, and also the parameters of the maze were a little bit confusing. But when we train our model in online, we figure out that it was easier, and it was impressive how the RL works and how it can learn very fast because we trained this model with only 10 episodes, and it can solve the maze right after that. And what was more impressive about the RL, I think, is that we can do a lot of things with it because in this project we have that reward function that can help us to achieve the goal, right? But if we want that the maze that the car can solve the maze with another initial conditions, we can train this car to do it. with more episodes, and if it has more episodes, we think that it can achieve it, right? Because the model, the car, follows a path that is made of an A-star algorithm to know the path to the end, to this path. But in conclusion, I think that it's better using the RL to solve this kind of problems, unless we only train this model with 10 episodes. But if we train it like with 15 episodes, and this is one of the limitations, because if we want to train it online, it's a lot of time. But with time, we can train it to do another routes, another paths, another turns, not only 45-degree turns. We can do a lot of maze solving. But thanks for watching, and I think that is very impressive, the RL, because not only we can use it in this project to a car, a mobile car, to differential wheel mobile car, it can be used with a lot of mechatronic systems that helps to improve it, right? Because it's memorizing and learning how to do it well. And that's it. Thank you for the attention.